Hey guys, hello and welcome to a new episode of the Path to DevOps series. I'm Shiki and today we're adding the final feature to our Ingress object, which we've worked on in the past few sessions of this series. And basically we're going to make the connection HTTPS. We're adding TLS by using something called Cert-manager, which is going to generate a certificate and validate a certificate for us based on a DNS host name. What we've done in the previous episode. So we are building on top of existing knowledge, and right now we are achieving the final level of professionalism, which is we're going to serve our front end on a host name, and the certificate will also be valid, meaning we will attain an HTTPS successful connection. So if this sounds fun and you want to understand how to do it all by yourself using Cert-manager and AKS in Azure, let's jump straight into it. As per usual, you will be able to follow along with the code in my GitHub account in the Path to DevOps Azure DevOps repo by selecting feature/03_TLS_cert_manager branch. And in there you will find the code with the changes to the chart and also a helper set of scripts and YAML files which will assist you in successfully deploying the Cert-manager. However, if this is still not extremely detailed, don't worry, because Cert-manager, so cert-manager.io, they actually have a pretty comprehensive set of tutorials for us. And if you click on get started right here, as I've just done, and the last one is learn how to deploy Cert-manager on Azure Kubernetes service, exactly what we're using, and how to configure it to get certificates for an HTTPS web server from Let's Encrypt. And that's exactly what we are going to do today. So if you click on this, you're going to have a very thorough walkthrough on what we need to do. However, we're not going to go through everything because we don't want to create a dummy certificate first and then make it production. We're just going to go straight to the production version and the valid certificate. And that basically happens here under part 2. So that's exactly where we're going to take off. If you follow along with this full tutorial from Cert-manager, in part 1 you'll create a test certificate, okay? We're not going to do that, as I mentioned. Right now we're going to configure Cert-manager to use Let's Encrypt and Azure DNS in order to create a trusted certificate for us, which we can use in production, basically securing our website with that certificate. And the way it works is we need to prove to Let's Encrypt that we own the domain, and then it will generate the certificate for us. If we prove that we own the domain, it will say, okay, I will generate a valid certificate for you for that domain name. And this is known as the DNS 01 challenge type. Okay, and we'll get into this a bit further into the video. As it says here, Cert-manager can create the DNS record for you by using the Azure DNS API, but it needs to authenticate to Azure first. And currently, the most secure method of authentication is to use workload identity federation. Okay, so today's solution is not extremely simple. There will be a lot of steps to follow along, but if you manage to do it, you will have a production grade web server which is HTTPS secure. So don't we all want that? Now, the thing is, we need to make some changes in multiple places. First one would be Kubernetes cluster. We need to apply some add-ons on our Kubernetes cluster in order to enable this workload identity federation. And I'll show you how in just a few moments. So I've taken myself off camera for a few moments in order to split screen and show you that everything you can find in this Cert-manager guide, in terms of commands, I've aggregated in a PowerShell script, not a real script per se, but basically it's easier to follow the story along if you read this, okay? So I'm not going to work in parallel starting now. I'm just going to look at the instructions.ps1 and I'll talk about what's happening as we go through it, okay? However, if you want to get more in-depth information, obviously look at the Cert-manager page, because in here everything is explained. In the PowerShell script, it's just the succession of activities. Now I'm back on camera. Let's continue with the script. So first things first, on the first line of the script, you will have the URL to that Cert-manager tutorial. If you need more information, if you want to just follow that along, perfectly fine with me, okay? This is just, as I said, better order for me in terms of what commands I should run in order to obtain the result, okay? Now we have a variable section here and I need to declare these variables, so I'll just paste these in the terminal and voila, this is it. Then we need to add the extension AKS preview and make sure it's updated to the latest version. And this will take a couple of moments. Let's do it. As you can see here, the extension is already installed and it's also on the latest version, so that's fine. Then we need to register for this feature right here. The feature is called Enable Workload Identity Preview. Yeah. And there we go. We are now registered, and you can actually run this query here on line 14, which will show you that the feature is registered. Okay. Once this is done and the feature is registered for you, we can update the AKS cluster to use the OIDC issuer and workload identity. So let's do that. This will take a couple of moments. Yeah, we're making an upgrade on an AKS cluster that's already existing. So I'll just fast forward this section and I'll see you at the end.
A few moments later.
Okay, the upgrade of the cluster has completed, as you can see here. And now the next step for us would be to install Cert-manager in this cluster. So Cert-manager is a component which we can install in the AKS cluster using HELM, and we are familiar with HELM, or we should be by now. The only thing I want to tell you is that we're not going to install the HELM chart default. Yeah, as you can see here, if I scroll to the rightmost corner, we are using a certain value file. Okay, so the value file, if I show you, is this. Cert-manager values. Yeah, and basically we are adding some service account labels and some pod labels, which basically tell Cert-manager to use the Azure workload identity. Okay, so the feature which we just enabled on the AKS cluster, we also need to teach Cert-manager to use it, and we can do this via this values file. So basically what we're running here is a HELM upgrade command for Cert-manager. Yeah, we are deploying it in the namespace Cert-manager. If the namespace doesn't exist, we create it. If the release doesn't exist, we install it. Okay, we set the install CRDs to true. CRD stands for custom resource definition. So basically Cert-manager will create its own set of objects inside of Kubernetes, and we'll talk about them maybe later. And then we also give it the value file. Yeah, in this case, that's the location of my value file. So I'll just copy this command and I will run it. And as you can see, Cert-manager successfully deployed, and this is the second revision because the first time I deployed it plain vanilla, yeah, Cert-manager. So if you didn't deploy it before, don't worry, this command will also work for the first time you deploy Cert-manager. It's fine. It's even though the command is upgrade, you have the install flag. So in case it's not already installed, it will install Cert-manager for you. Okay. And once this is done, in order to validate that the changes we've made are there, you need to run this command here. Yeah. kubectl describe pod namespace Cert-manager and look for these labels. So running this will show us a lot of output, obviously. And what we need to look at is, first of all, you need to have volumes and you need to see a set of projected volumes. Yeah, Kube API access and Azure identity token. These should be projected tokens. And also if you scroll at the top under environment variables, you should be able to see some Azure environment variables mounted on the pod. Okay, so if you see this, it means you are on the right track and you've enabled this workload identity on the Cert-manager. Now, moving forward, we need to create a managed identity resource in Azure. A managed identity is an Azure resource which acts like an app registration or a service principal, but in this case, you don't need to manage its set of credentials like secret or certificate. The managed identity is just managed by Azure. Yeah, so you create the object and Azure takes care of rotating the keys in the backend for you. You just use this identity and you can assign RBAC roles to this identity at a certain scope. So what we're going to use this managed identity for is it will allow the Kubernetes cluster to perform various activities on the DNS zone in order to validate that we own the DNS zone, and then Let's Encrypt will generate the certificate for us once we validate that we own the DNS zone. Once the managed identity is created, we can use the command on line 24 and when we run it, it will store inside of a PowerShell variable the ID of this managed identity we just created. Okay, you can see it here. So moving a bit down the line, it says here replace managed identity client ID in the ClusterIssuer.yaml on the client ID property. So that's exactly what I want to do now. Okay, this is a Kubernetes object. It's a CRD, which means custom resource definition, and it's a custom resource definition deployed with the Cert-manager. Yeah, it's called the ClusterIssuer, and you can think of it like a certificate authority that lives inside of your Kubernetes cluster and starts the certificate signing request process for you. In here, you will need to configure this with your own information. Yeah, I'll just show you quickly what fields you need to complete. The first one is the email. In this case, this is my email address. Then you need the resource group name where the DNS zone will sit, the subscription ID in which the DNS will sit, the hosted zone name is the name of the DNS zone you want to prove you own. In our case, it's going to be dev.barbar.ro. And then you need the managed identity client ID, and this is the managed identity we just created. So once you've created this, we will deploy it in a few moments. Now back to our instructions. We need to create a role assignment for the DNS zone. So basically, we are giving the managed identity we just created the DNS zone contributor role on our DNS zone. In our case, there's a small problem. I didn't create the child DNS zone yet. Okay, so as I told you, we're not going to use barbart.ro. We actually want a child of barbart.ro. So that's exactly what I'm going to do now. Yeah, I'm going to go on my root DNS zone and I'm going to create a child zone. And I want this in the same subscription as the Kubernetes cluster. So that's exactly what I'm going to do. I'm actually going to put the DNS zone in the same resource group as the Kubernetes cluster's resources. It will make it easier for me to delete it later on. And then the name of the zone will be dev.barbart.ro. So let's review this. And validation passed. So let's create the resource. It will take a couple of moments. And again, just to make things clear for you, if you scroll at the top, you will see here DNS zone dev.barbart.ro. Yeah, so you need to make sure this DNS zone exists for you. I haven't created it prior, so I'm creating it now to show you exactly how I'm doing it. Okay, but in the end, when we create the role assignment, the DNS zone needs to exist. Okay, so we're giving the managed identity DNS zone contributor role on this scope, and this scope is basically getting the DNS zone ID. Okay, that's basically what we're doing. So now that the DNS zone is successfully created, as you can see here, I'm going to run the command and create the assignment. And as you can see here, the assignment was successful. Yeah, no error, nothing red. All right. Now, what we need to do is we need to add a federated identity, okay, between Kubernetes and this managed identity that we created. So I'm going to declare 3 more variables. There we go. And then we will get this service account issuer. Yeah. So if you look at the service account issuer, this is how it looks like. Yeah, it's just a URL. And now we're going to create this identity, yeah, this federated credential between the managed identity and the issuer of the Kubernetes cluster. Okay, so we're running this command now. Okay, and now the final step of this process is to actually create the cluster issuer, which we configured earlier on. Okay, so it's going to be our certificate authority inside of Kubernetes. So I'm going to copy this one and just create it. Yeah, and successfully created inside of Kubernetes. And now you can actually describe it using kubectl command. Yeah. So kubectl describe cluster issuer, and as you can see here, if you look at the issuer, yeah, there's a lot of information, but at the bottom you need to look and see that the account, the Acme account, is registered, yeah, and everything is working as supposed. The final piece to our puzzle at the moment is to actually make changes to the Helm chart, which deploys our 3 microservices from the Barbart stack. And we need to actually add a bit of code on the Ingress object so that it can be TLS secured. Yeah. So if we go to the Helm chart here and we expand templates, I've already added the changes, but it's not a big load of changes. It's just these 4 lines. Okay. So you need to add a TLS section in your Ingress object. Yeah. Transport layer security. And then you need to repeat the host. Yeah. The host header here. And you need to use the same values Ingress host. And then you just give it a secret name. Basically, inside of this secret, the Ingress will store the certificate, which it will use for SSL offloading. Okay, so that's all you need to add inside of the ingress.yaml manifest. And in terms of values.yaml, as I said, I will change the host. So in our case, we will sit on the subdomain dev.barbart.ro. I will have a FE record with the IP address of the Ingress controller created there. We'll do that in just a moment. And also you need to make sure you add one annotation, which is this one. Yeah, it's cert-manager.io/ClusterIssuer, and then this is the name of the cluster issuer. So if we look at this, yeah, let's encrypt production and let's encrypt production. Okay, so this should basically settle everything. Allow me to push changes into my tools repository. So now I'm pushing everything. This should do it. Now let's do kubectl get service namespace networking. Yeah, that was what I was looking for. And this is the IP address of the Ingress controller. Yeah, you can see it here, controller Ingress-nginx controller. This is the external, the public IP. So I need to create my record here. So I'm creating a new record set in my DNS zone. Allow me to move myself so that you can see. And in here, I'm creating the fe.dev.barbar.ro. It's going to be an alias. Yeah, so type A, and I'm going to paste the IP address and I'm going to hit OK. Right? Now that we've pushed our changes to Git, we need to run the front-end deployment pipeline one more time. And once this is deployed, we will be able to see if our certificates are successfully created and if we have our HTTPS web server deployed. Okay, the pipeline completed successfully. Let's look at our certificates and see how they look like. So if you do kubectl get certificate, in the namespace, in my case it's shiki-ns, you will see there's a new certificate created, and at the moment it's not ready yet. Yeah, it's false. So let's look at the challenge. And there you go. Yeah, you have the challenge created for this domain. So let's look at the Azure portal. As you can see here, just as I mentioned previously, in your DNS zone, there's this challenge text file, which was created by the cluster issuer inside of your Kubernetes cluster. So basically you said, I want a certificate for fe.dev.barbart.ro, and then the cluster issuer deployed in our cluster used the managed identity which we created to create this front-end challenge. Yeah, and then it's going to query the DNS for this text record. The Cert-manager will query DNS for this text challenge, and if it finds it, then it will conclude, yeah, okay, this guy owns the domain, and by that it will validate the certificate for me. So now when we refresh, you see the challenge disappeared. So this means the validation, the DNS01 validation was done successfully. And if we go here and we look at the certificate once more, you will see it switched its status from false to true. So now our certificate is ready. Let's look at the ingress. And you see the host here, yeah, fe.dev.barbar.ro. So I'll copy that. I will paste this here, and it's asking for obviously the basic authentication, which is Marco and then Polo in my case. Come on, there we go. We have the front end. We are able to click on buy now and we should get the pop-up, and here it is. But the most important feat of all is, actually I cannot zoom this in, but you can see here the padlock. Yeah, the site is secure. Connection is secure, and if you look here, certificate is valid. So in here, if you look, you'll see that it was issued by Let's Encrypt for us, and it was issued on Thursday, March the 2nd, and it will expire on Wednesday, May the 31st. But the good part about this is because we are using Cert-manager to manage our certificates, this validity period, whenever it will approach expiration date, Cert-manager will regenerate the certificate for us. Yeah, so we don't need to do anything anymore. Right now, the cluster issuer, which is the certificate authority running inside of our Kubernetes cluster, knows that we own that DNS domain, and because of this, it will cycle the certificates for us every time they approach expiration date. Yeah, so this is a very cool automatic way to obtain certificates for domains that you own. So let's wrap things up with a bit of schemes and diagrams and understanding what happens under the hood with Cert-manager, the cluster issuer that we deployed, and how the process happens. Okay, so first things first, let's go to Kubernetes and do kubectl get crd, and these are custom resource definitions. Yeah, so you can see some of them have this suffix here of cert-manager.io. So we have certificate requests. This is a type of resource in Kubernetes which is not default, it's custom. We just deployed it with the Cert-manager. We have certificates, we have challenges, we have cluster issuers, we have issuers, and we have orders. Yeah, so all of these resources were deployed today by us when we installed the HELM Cert-manager chart. Yeah, now that these are created, let's see how they interact in order to generate this certificate for us. So the way we start our journey is inside of our Ingress object. We modified our Ingress object to add TLS to it, yeah, at this host, and we told it that it should store the certificate for TLS inside of this secret. And in the values file, we also told it as an annotation that it should be using this specific cluster issuer to issue the certificate for us. So how does this process happen? Well, first of all, certificate resource. Yeah, when you create the Ingress object with the Helm chart, you reference the issuer, the cluster issuer in our case, and a certificate gets created. Yeah, so this is a certificate resource coming from Cert-manager. Yeah, this custom resource definition right here. Okay, so we create the certificate. This certificate references the cluster issuer in our case. Okay, and it will need to sit inside of a secret mentioned in the Ingress object, which does not exist yet. So this will trigger the controller for issuance or reissuance. In our case, it's issuance. It will switch status to issuing and pending, obviously, and then it will create a temporary secret with a temporary private key. Yeah, this is not the final private key generated by Let's Encrypt because we didn't validate that we own the domain yet. Okay, so right now all that happens is we have a certificate with a certain status, which is issuing pending, and also a secret gets created with a temporary secret. Then the certificate will switch and we'll add this revision here, which says null or nil. Yeah, and we'll create a certificate request. This is a Kubernetes resource again, custom resource definition. Yeah, certificate requests.certmanager.io. So this belongs to the Cert-manager ecosystem. And basically what happens here is this is the certificate signing request that we are creating. Okay, then the certificate signing request will create another Kubernetes object, which is called order. Yeah, you can see it here, orders.acme.certmanager.io. And this order will create challenges. And in our case, it will create a challenge for each domain. It was that text record you were able to see here in the DNS zone and that disappeared at the end. Okay, so the challenge itself is tasked with creating the text record inside of our DNS zone. Then Let's Encrypt works out the challenges. So once the challenge creates the record inside of the DNS zone using the managed identity, which we created like 20 minutes ago, then Let's Encrypt will query our DNS text record and see if it's existing. So if the challenge managed to create that text record in our DNS zone, obviously we are the owners of the DNS zone. So then Acme Issuer will issue the certificates for us, and then it will fetch those signed certificates from Let's Encrypt. The challenges will be removed after use. The order will populate with the certificate, and it will transfer the certificate to the certificate request, and also the order will be removed after use. And then the certificate request will put the information, will bubble up the certificate as it says here inside of the certificate object, and then the certificate object will be added to the secret referenced in the Ingress object. Okay? And in the end, the temporary secret is also removed after use, and we are left with a valid certificate, a secret which contains the certificate and also the certificate request. And we can check this using kubectl. So kubectl get certificate namespace shiki ns, and you can see the certificate here. Let's get the certificate request as well. Yeah, this is also here. Let's try to get the order. Yeah, the diagram said that the orders get destroyed. So now it's valid. It didn't get destroyed actually. Yeah, this will be, it says here it's removed after use, but in our case we still have the order which is valid and sits here. Let's look at the challenges. Yeah, so no more challenges. The challenges actually got removed after use. And in the end, we also have the secret which contains the certificate. So if we do kubectl get secret namespace shiki ns, you will be able to see that we have frontend TLS. Yeah, it's a Kubernetes secret which was created 16 minutes ago. I really hope this will get you started with using Cert-manager inside of your Kubernetes clusters in order to create this ecosystem of self-managing, self-servicing certificates which get created for you by Let's Encrypt, as long as you own the DNS domain, obviously. And I genuinely believe this will make life easier for you in Kubernetes long term, and that in the end you will be able to offer a higher quality to your clients. Because right now you are serving HTTPS front ends, right? So who doesn't want that in nowadays era? All right, guys, this is it for today. Thank you very much for giving me your time. I really hope this is useful for you. Let me know down below in the comments if you would like to see more things, and I'll see you next time when we transition from actually adding functionality to the Ingress to more infrastructure oriented stuff and actually adding in infrastructure as code. So if you're looking forward to that, subscribe to the channel and I'll see you next time. Thank you very much. Cheers.